Right, so this is a 6-mark question. So because it's one of the extended writing questions, we've got to make sure that we do our spelling and grammar correctly. We need to make sure that we're writing in full sentences. But first of all, we're going to highlight in the question some important points. So if we just read the question, it says metals are extracted by different methods which are linked to their position in the reactivity series of metals. And then it tells us 3 things. It tells us that zinc is extracted from its ore by reduction with carbon, silver is found uncombined in the Earth's crust, and sodium is extracted from its ore using electrolysis. So then it goes on to say, below is a reactivity series with 3 metals missing. Use the information given about the extraction methods to work out where zinc, silver, and sodium fit into the reactivity series. So I'm just going to highlight a few points. So first of all, zinc is extracted from its ore by reduction with carbon. So I'm just going to underline that. I'm just going to put a note by that. So we extract metals from their ore using carbon when they are less reactive. So that means that zinc is less reactive than carbon. Otherwise, the reduction with carbon doesn't work. It then says silver is found uncombined. I'm just going to underline that. So uncombined, I'm just going to write next to that what that means. So if it's uncombined, that means it's not reacted with anything, any other element. So that would indicate that it's the least reactive element. So in that case, that's going to tell us that silver is very unreactive. It's probably going to be the least reactive. I'm just going to underline that there so we can see that that's what I've added rather than what's in the question. And then it says sodium is extracted from its ore using electrolysis. Again, I'm just going to underline the electrolysis because that's the important thing here. So we use electrolysis when the metal is more reactive than carbon. So this means that sodium is more reactive than carbon. You can use electrolysis for the other methods, but it's more expensive. And it's more expensive because a lot of electricity is used. Right, so we can now use this information to answer the question. So it says use the information given about the extraction methods to work out where zinc, silver, and sodium fit into the reactivity series. So it's not enough, because it's a 6-mark question, I can't just place the metals in the correct place. I've got to explain why they're in that place. So I'm just going to write underneath of the question. Just let me get my formatting right. So here's my model answer. And remember, I've got to write in full sentences and correct spelling and grammar here. So in between potassium and aluminium, so I've got to decide which one goes there, and I've got to decide the one that goes between carbon and iron, and then copper and gold. So from those bits that I've highlighted, I can see that silver is the least reactive because it's uncombined. So I'm going to go with that one first. So let's put silver here. Place that in the correct place. Let me just highlight that in bold so you can see that that's what I've done. Let's make it consistent and underline it because that's what we did with the others. Right, so now if I go to my model answer, so silver is placed between copper and gold in the reactivity series. This is because it is the least reactive of the 3 metals. Now I need to explain how I know that. So I know it is the least reactive as it is found uncombined in the Earth's crust, which means that it hasn't reacted with any other element. Okay, so that's my explanation for silver. So now I'm going to look at the one between carbon and iron. So the one between carbon and iron is less reactive than carbon. And if I look at my notes up here, I've said that zinc is less reactive than carbon, and we know that because it's extracted from its ore by reduction. So I'm then going to put zinc, so I need to say where it's going and then explain why. So zinc is between carbon and iron in the reactivity series. This is because it is less reactive than carbon. We know it is less reactive than carbon because carbon can be used to extract zinc from its ore. And we should probably talk about what that process is. So we know that that process is reduction with carbon. In fact, we don't need to say that because it's in the question, isn't it? Right, so we know it's less reactive than carbon because carbon can be used to extract zinc from its ore. So we'll just put a quick note here because we know that you can use electrolysis for that. So electrolysis could be used. Sorry, I misspelled that. Could also be used to extract zinc from its ore. However, it is much more expensive than using reduction with carbon. So electrolysis is only used when the metal is more reactive than carbon. Right, so that just leaves aluminium, just leaves sodium. So sodium, we need to see where it is in the reactivity series. So sodium is between potassium and aluminium in the reactivity series. Okay, we know this because it is extracted from its ore using electrolysis. This is a bit of a repeat of what we already said, but this is only used when the metal is more reactive than carbon because it is a very expensive method. And then we can explain why reduction with carbon doesn't work. So reduction with carbon will not work as there will be no reaction. And this is because a displacement reaction only works if the metal element, no, actually in this case it's not metallic, it's carbon, so I can't put that. So displacement work only works if the element is more reactive than the one in the compound. Okay, so there's your answer. So you need to transfer that to your model answer sheet, and then you should also have been given this other question here that's a different 6-mark question, but it's along the same lines. So there's a bit less structure to this one, but use what we've done on this question to have a go at that one. Okay, thank you for listening.